5.6, exploring inverse functions. Now, we talked about at one point last year direct variation. Now we're talking about inverse variation. So notice that instead of it being side by side, now it's over top of one another. And the inverse of something is usually the flip, right? Or the reciprocal of something. So that's what we're going to be working on today, is finding the inverse operations. Okay, so let's start out with a function. So let's start out, I'm going to use function notation. F of x is equal to 2x minus 3. So the first thing I want to do is recognize that this is really a y equals, correct? Okay. And the first step in finding the inverse of this operation would be to flip x and y around, okay? So I'm going to put an x where the y is and a y where the x is. And then I'm going to solve for y. Just like I was up here, I want to solve. Okay, so if I want to get this all by itself and I onion this out, the first thing I'm going to do is I'm going to add 3 to each side. Okay, so I have x plus 3 is equal to 2y. And then I'm going to divide by 2. Now, who am I going to divide by 2? I'm going to divide everybody by 2. So notice, what's the number in front of this x? You're right, it's a 1/2. X plus 3/2 equals y. Take a second to kind of look at how I wrote that, especially the 1/2 piece. Okay. And this is the inverse of this function. Okay. So I want to take a second and I want you to think about inverse. Okay. Now be careful, because the inverse means that I'm flip-flopping, okay, the x and the y values around, okay? So if I were to plot these, the x and the y values just flip. Now be careful, this does not mean that, okay, so I want you to take some graph paper, okay? Oh, sad face. And then we're going to graph these two, okay? So I'm going to graph this first one. So y is equal to 2x minus 3, okay? So real quick, this is my slope, right? And this is my y-intercept. Okay, so my y-intercept's -3. 1, 2, 3. Okay, that's a really bad, sorry about my axes. Now my slope is 2, so that means up 2 and over 1. All right. Okay, so that's that line. All right, I'm going to take my red pen and I'm going to do this. Okay, now I can see how this is flipped? You know, that makes sense, 2 and this is a 1/2, but this looks weird, doesn't it? Okay, so this is a positive 3/2, so that's 1 1/2, right? Okay, so that's up here. And now I'm up 1 over 2. That's really strange, isn't it? That's not necessarily what you might think when you're thinking inverse, okay? You're like, whoa, that's really weird. Okay, it's not a flip across, okay? Kind of strange, don't you think? We're going to come back to that, okay? So that's our first one. Let's do another one. Okay, let's do another one. Let's do this one. Do I want to step? You know what? Let's go back. I'm not sure we're ready. We're ready for stepping up there in that department right there. So let's try this one. Let's just do a simple x minus 2. Okay. All right. Find the inverse. So step number 1, flip x and y. Put the x where the y was, put the y where the x is, and we're going to solve for y. Okay. So we're going to add 2 to each side. Wow. That was easy. Let's go let's go and see if we can kind of see what's going on. Okay? See what we got going on here. All right, so the top one has a y-intercept of -2, up 1 over 1. Okay. All right. This one has a y-intercept of 2, up 1 over 1. They're like parallel. That's weird. That's weird. Okay. Kind of flipped across. It is kind of strange, isn't it? Huh, because the inverse of 1 is really 1, isn't it? So it's not just flipped across the x-axis or the y-axis, because technically I'd be opposite for the y-axis. Well, let's keep exploring, okay? So now what we wanted, so these are both linear. These were lines, right? So now we need to get into what do we do with cube root and what do we do with square roots? Okay, well, that's why we're waiting on this section, okay? So right now, this is a parabola, okay? I want to find the inverse of it, okay? So step number 1, flip x and y around. Hey friends, well you can do this. I know you can. So the first thing I'm going to do, if I have to onion this out, okay, is getting rid of that 2. So divide by 2 on each side. So that's like 1/2 x, isn't it? Y squared. Okay, well what's the opposite of squaring something? Well, you just took a test on that. That's square rooting. And when I square root, I put a plus and minus, right? 1/2 x is equal to y. Huh. Well, that's really weird, isn't it? So remember that you have a parabola, right? And parabolas go like this, correct? Well, how do square roots look? Well, they look like this, right? Well, if I have, this is the plus part, well, the minus part is going to look like this, isn't it? Whoa. So we're literally taking a parabola and flipping it on its side. That's really weird. So a couple things that you need to think about. Sometimes when we look at these problems, they're going to give you a set of domains that you want, and you might just be doing the plus or the minus piece of that, okay? It might be one or the other. Okay, so let's graph this, okay? And we'll start out with doing the parabola, and we're going to just do a set of points, okay? We're not going to do x squared. I could do negative b over 2a if I wanted, but I will tell you that if we did negative b over 2a, you'll notice there is no b, right? So the vertex is actually at 0, 0, okay? So that's nice to know we're going to start there. Can you tell me what the slope might be? Yeah, you're right. It's 2 over 1. So up 2 over 1 for our parabola. What I do to one side, I do to the other. So draw your parabola up like this. Absolutely. Okay. Now, if you stop and think, let's write down these points. Okay, let's write down these points. This is what? 1, 2, and this is negative 1, 2. Okay. Now let's think about for our other piece, okay? Our other piece down here. So the y is equal to the square root of 1/2 x, okay? So let's think about that. And remember, we have a plus and a minus. So let's think about the x and y. So if I plug in, if I do my 0, I still get a 0, don't I? Let's do this for the plus, okay? And then we'll think about it for the minus part, okay? Or how about this? Once we do the plus, we'll just mirror the minus. All right. Well, let's see. If I plug in, let's not plug in a 1 here. Let's plug in a 2. Here's why. What's 2 times 1/2? Well, that's 1. And what's the square root of 1? Well, that's 1. Okay. And let's do our fancy 4, right? What's 4 times 1/2? Well, that's 2. Ooh, square root of 2. That's not good, is it? Ugh. Well, you know what? Let's just stop right there and we'll just do those two because I only have 2 points here. So here we go. 0, 0. So I'm in the same spot. 2 over 1. And I'll just draw it like that. Okay. So, friends, if I'm going to do the minus, that's just mirrored across here, isn't it? So I'm just going to do the mirror. Whoa, look at that. That's kind of cool. Wait a minute. Hold the phone. Look at this. Whoa, wait a minute. Those are just flipped. Wait a minute. That's what this is all about. I'm just flipping my X's and my Y's around. Holy mackerel. That's exactly what it is, friends. You're just flipping. And you know what? Here's the other cool part. The other cool part is talking about that this inverse, you know how I switched the X and the Y around? This inverse is actually over the line Y is equal to X. Look at this. Imagine if I were to fold this paper on this line. This line is Y is equal to X. Has the origin, up 1 over 1, has slope. If you were to fold this paper, would those be right over top? And they would, okay? So let me see if I can draw that over here. Remember our 2 over here? So let's look at this. Whoa, look at that. If I were to fold it, they'd be right over top of one another. How about this one? You know what? This one also has the same slope. Cool. If I were to fold this, would I be right over top of one another? I would. Okay? So that's really what you're doing. Your inverse is mirroring over the line Y is equal to X. Okay? You got me all figured out, friends. So it's really weird when you stop and think about it and you're flipping, it's really quite cool. Okay? So I love that. So when you think about it, you're flipping it from here over to here. Okay, let's try a cube root. Okay, so let's do this. Y is equal to negative x cubed plus 3. And we're going to do this one on our calculator. I'll show you how to do it on the calculator. Okay, so step number 1, go ahead and flip x and y. So x goes in for y, and y goes in for x. Okay, so if I were to onion this out, okay, I want to get rid of that 3 first. So I'm going to minus 3 on each side. X minus 3 equals negative y cubed. Get rid of that negative. We don't need that. So guess what? Everybody's got to switch signs over here. So this is going to be a negative x plus 3 equals y cubed. All right, what's the opposite of cubing something? Cube rooting it. So you're going to cube root this whole thing. Now, do I have to put a plus minus in front? Nah. Okay, I do not. All right, now remember, so a cube root is like a sideways snake, right? So when you think about a cubed function, it kind of looks like that. So watch, I'm going to show you how you can put this on your calculator and you can kind of see this. So the first thing you need to do is go to your y equals, make sure you clear stuff out, okay? So let's put in our first function. So negative x to the third, okay, plus 3. So I just want to see, what this looks like, okay? Oh, that's kind of cool. Looks like it's moved up 3, and look at, it's like a roller coaster. Now, why? Notice that I'm heading down, right? Because of the negative that's located there, okay? So imagine this, and imagine it's getting flipped along that y equals x. So let's go back to our y equals, okay? Let's go down to the second y squared, and let's put in our inverse variation. Okay, if you'd like to use the math button and do the cube root, you can certainly do that. There we go. Oh, there we go. That's a little bit clearer, isn't it? So negative x plus 3. Okay, and let's, oh, well, that's cool. I didn't have it drawn quite right there because of the negative. Huh, that's neat. So it's taken this and it's kind of flipped it the other way. So notice it comes down like this. All right, so just to show you how this is a mirror, let's go back to y equals real quick and let's put in our inverse, okay? So remember that your orange line is y is equal to x, okay? So let's see if it mirrors it across there. Oh, cool. Look at that. And if you were to fold this together, they would be right over top of one another. Isn't that neat? That's pretty cool. Okay. So we can use our calculators to graph these and stuff. But this is the first step on to 5.6. Okay, friends, is finding the inverse. All right. Thanks a lot.